Hey guys, today I'm going to be teaching further differentiation. So we've got an example here, we've got some implicit differentiation here, and just a more complex one up here. So if we just start with a, so a x to the power 4 minus 3x squared y plus 2y cubed minus 4x equals 7. So the first term is quite easy, so we just got 4x cubed. And then here we've got more than one term. We've got x's and y's here. So you can do the chain rule or you can just do it in your head. So I'm just going to leave that for now, and then I'll do the chain rule in a sec. And then here we've got one with y. So 3 times 2, like you would, times the power down. Take 1 off the power. But when you differentiate with y, we have to add dy by dx at the end. And then minus 4x just goes to minus 4. And then 7 goes to 0. It's a constant. And then here, we can say u equals 3x squared, and then du by dx equals 6x. And then v equals y, dv by dy equals 1. But being as we're differentiating with y, we have to add the dy by dx. And then what we do then is we times these two, and then we times these two. So if we start off with the first one, so 3x squared, and then we've got times dy by dx. And then we've got y times 6x, so 6x y. So then if we just move this out of the way, you can carry on then. So being as this is a minus here, it's minus the whole thing, so we have to times the minus out. So 4x cubed minus 3x squared dy by dx minus 6xy plus 6y squared dy by dx minus 4 equals 0. And then we'll just keep all the dy by dx's on the same side, so minus 3x squared dy by dx plus 6y squared dy by dx, and then move all the other terms over. So the 4x cubed will go to a minus 4x cubed, and then 6xy will go to a plus 6xy, and minus 4 will just go to 4. And then we can factor out the dy by dx here. Sorry guys. Yeah, factor out the dy by dx, so we have minus x squared plus 6y squared. And then here we could factor out 2 or minus 2 to see if we can cancel the minuses. So we'll take out the minus 2 here, and then 2x cubed, and then plus 3x, minus 3xy to make it a plus, and then minus 2, and then dy by dx equals minus 2x cubed minus 3x minus 2 over minus 3. Well, we can probably factorize something out here. We could take a minus 3 out. So we'll take out minus 3, then we've got x squared on the inside plus, minus 2y squared. And we can cancel these minuses here. And then we can say 2 over 3, 2x cubed minus 3xy minus 2 over x squared minus 2y squared. And then that would be our answer. And then B, it says we've got an implicit differentiation question. So x equals 7t plus 2t squared, and then y equals 4 plus 3t over 7 plus 4t. So differentiate this one, so du by dx, dx by dt equals 7 plus 4t, and then dy by dt, and we've got two terms in a fraction, so that's equal to u over v. So if this is u, so we just write out the rule for differentiating fractions. So that is v du by d, or here it's dt, but it can be dx, u dv by dt, and then all of that over v squared. So if we get a du by dt, so the u is 4 plus 3t, so we've got 3, so du by dt equals 3, and dv by dt equals 4, because the constants go to 0. So by using the quotient rule now, we've got our values for du over dt and dv over dt, so we can go ahead and do it. So v times du over dt, so we've got the bottom times the derivative of the top, so we just write it nicely by writing this one first, and then we've got minus the top function times the derivative of the bottom. So we've got minus dv, so 4 plus 3t, and then all of that over v squared, which is 7 plus 4t squared, and then we just times out the brackets. So 21 plus 12t minus 16 minus 12t over 7 plus 4t squared, and then we can cancel out these, and then we've got 21 minus 16, which is 5, and all of this over v squared, which is 7 plus 4t squared. So this is our dy by dt, and the question is asking for dy by dx. So dy by dx equals dy by dt times dt over dx, because we need the dy on the top, dx on the bottom, and we need the dt's to cancel. So like that. So we're just going to flip this. So this is, so dt over dx is 1 over 7 plus 4t. So then dy by dt is what we just worked out, which is 5 over 7 plus 4t squared times 1 over 7 plus 4t. So then we've got 5 over 7 plus 4t cubed. So k equals 5, n equals 3. Just making it a bit easier for the examiner, because that's what they were asking for us to find the constants. So this is I, and then II is asking for d2y over dx squared, so we've got a second derivative. So the rule for that is, so d2y over dx squared equals d over dt of the dy by dx times dt over dx. So dy by dx we just worked out by here, so we want a derivative of this. So if we just write it in a more appropriate way, so d over dt of 5, 7 plus 4t to the power of minus 3, because we brought that up, times dt over dx, we just found that as well, which is 1 over 7 plus 4t, 1 over 7 plus 4t. So if we want the derivative of this, we could do the chain rule. So if we do the derivative of the whole thing, so times, take 1 off the power, times the power down, so minus 3 times 5 is minus 15, take 1 off the power, take 1 off the power is minus 4, and then we also have to do times it by the derivative of the inside, which is 4, so times by 4. So we've got minus 60, minus 60 times 7 plus 4t to the power of minus 4. And then we also need to times by 1 over 7 plus 4t, so we can't forget about that. So we could do it like this, 7 plus 4t to the minus 1. And then just your power rules. So if you remember, if x is to the power of n times x to the power of y, then x equals n plus y. So minus 60 times 7 plus 4t, and minus 4 plus minus 1 is minus 5. So we've got minus 60 over 7 plus 4t to the power of 5.